We often want to build a chatbot with a chat history. We need to add a memory to the app. In this video, I'll show you how to add chat history to a RAG app. Here are the topics we'll cover. First, we'll create a virtual environment. Next, we'll initialize the local model with Ollama. And then, we'll load data for the RAG app. After that, we'll index the data. Lastly, we'll create a chain with the chat history. Nice! We've seen the topics we'll handle in this video. Now, let's go to the VS Code editor and then install the tools we'll use. First, we're gonna create a virtual environment with Conda. Let's write Conda create. Let's give a name Gen AI. I already created this. After that, we're gonna activate this environment. Let's do this. Conda activate Gen AI. Okay, our environment is ready to use. What we're gonna do now is install the tools we'll use. To do this, let's create a requirements.txt file. We're gonna click on the new file and then name it requirements.txt. After that, let's write the tools we'll use here. We're gonna type LangChain and then LangChain community. As the vector database, we'll leverage the ChromaDB. Lastly, to extract data from a website, we'll use BS4. For now, these tools are enough to build the app. We're gonna now install this. To do this, let's use pip install -r. Let's write requirements.txt. There you go. Our tools are ready to use. To write our code, we're gonna create a notebook file. Let me click on the new file and then give a name rag.ipymb. Okay, our notebook is ready. Note that we're gonna use a local model with Ollama. Ollama allows you to run open source LLMs such as Mistral and Llama 2 locally. All you need to do use these models is download this tool and then install it on your computer. After installing, you can use this tool in your terminal. To load a model, type Ollama pool and then write the model Mistral. This is simple, right? To see the installed models, use Ollama list. There you go. The model we'll use is Mistral. The embedding model we leverage is Nomic Embed Text. I already pulled this model. Cool, we've seen the models we'll use. Let's go ahead and initialize our local model. To do this, we're gonna use the Ollama class from LangChain. Let's write from LangChain community. Let's write LLMs import Ollama. Next, let's initialize the Mistral model. LLM equals Ollama. Let's set model. It's gonna be Mistral. Okay, our model is ready. Let's take a look at how this model works. To do this, let's write LLM. Let's call the invoke method. Let's pass tell me a short joke. There you go. Our local model worked very well. Nice. Our model is ready to predict. Let's go ahead and load data for RAG. The data we're gonna use is related to LangGraph. LangGraph is nothing but an amazing tool built on top of LangChain. It allows you to assign the computational capabilities to your LLM app. What we're gonna do now is load the blog post context about LangGraph. This blog post explains what LangGraph is. For RAG, we're gonna use this post. First, let's load this post using document loaders. To do this, we're gonna import the web-based loader class from this module. From LangChain community document loaders import web-based loader. Next, let's load this post using this class. First, let's initialize an object from this class. Let's say loader equals web-based loader. Let's set web path. Let me pass the link. Now we can load the web page using this object. Let's say docs equals, it's gonna be loader load. That's it. Our data is ready to use. Now we need to split the document into chunks for embedding and vector storage. This should help us retrieve only the most relevant of the blog post. To do this, we're gonna use recursive character text splitter. This class helps us recursively split the document using common separators like new lines. First, let's import this class from LangChain text splitters import recursive character text splitter. Next, let's instantiate an object from this class. Let's say text splitter equals recursive character text splitter. We split our documents into chunks of 1000 characters with 1000 characters of overlap between chunks. Let's set chunk size. Chunk size equals 1000. Let's set chunk overlap. Overlap is nothing but a small amount of text between chunks that help preserve context. Let's write chunk overlap 200. We're gonna set h index equals true. This helps us add a metadata attribute. Nice! We initialize an object to split our text into chunks. The next step is to apply this class to our text. All split equals text splitter. Let's call the split document method. Let's pass docs. There you go. Our text is split into chunks. What we're gonna do now is index these chunks. This helps us search over them at runtime. To do this, we're gonna embed the contents of each document split and insert this embedding into a vector database. The embedding model we're gonna use locally is the Nomic embed text model. First, let's import this model with Ollama from LangChain community import embeddings. Next, let's get the model using this method. Let's say embedding equals embeddings Ollama. Let's call the Ollama embeddings method. Let's set model equals Nomic embed text. Okay, our model is ready to embed. The vector store we're gonna use is Chroma. Let's import this vector store from LangChain community. Let's type vector stores import Chroma. Next, let's initialize an object from this class. Let's say vector store equals Chroma. Let's call the from documents method. Now we're gonna paste our documents and embedding. Documents equals all split embedding equals embedding. Cool! Our vector store is ready to use. Note that we wanna create a simple app. This app will take a user question, search for the documents relevant, and return an answer. Now we need to define our logic for searching over documents. We are lucky that LangChain defines a retriever interface. This interface helps us return relevant documents given a string query. The most common type of retriever is a vector store retriever. This class uses the similarity search technique. Let's create a retriever. Retriever equals vector store. Let's call the sRetriever. Let's set the search type parameter. Search type equals similarity. And then let's specify tab key. To do this, let's write search quarks equals k6. Nice! Our retriever is ready to use. let's explore how it works. We wanna know what LangGraph is. Let's take a look at a document related to this text. To do this, we're gonna use the getRelevantDocuments method. Retriever dot, let's call the getRelevantDocuments. Let's pass what is LangGraph. There you go. Here you can see the 6 documents related to the text. Yeah, it's time to create prompts to add chat history. First, we're gonna define a subchain. This chain will take a historical messages and the latest user question and reformulate the question. Now, let's create a system prompt to contextualize. To do this, first, we're gonna import chat prompt template and messages placeholder from LangChain core. Let's write prompt import chat prompt template and messages placeholder. Chat prompt template help us create a prompt template. Messages placeholder is a way to pass in a list of messages to the prompt using the chat history input key. Now let's get a system prompt. To do this, let me copy a prompt and paste it here. This prompt helps us formulate the latest user question based on a chat history. Next, let's create a chat prompt using chat prompt template. Let's say contextualize q prompt equals, let's set chat prompt template. Let's call the from messages. First, let's set our system message. System. Let's set our contextualize q system prompt. Next, let's set message placeholder. Remember, this will ensure that a list of messages is passed to the prompt. Messages placeholder. Let's set the variable name. Let me paste chat history. Lastly, let's set a human message. Human. Let's give question. We're gonna use curly brackets. Nice! The system prompt is ready to use. To use this prompt, let's create a chain. Contextualize underscore q underscore chain. First, let's set contextualize q prompt. Let me use pipe. And then let's give our local model. And then let's pass str output parser. To use this class, let me import this from LangChain core output parsers import str output parser. Awesome! Our chain is ready to use. Let's test it. To do this, we're gonna use the AI message and human message classes. First, let's import these classes from LangChain core messages import AI message and then human message. After that, to perform the chain, let's call the invoke method. Let me write our chain and then let's call the invoke method. First, let's create a chat history as an example. Chat history human message. Let's set the content. What does LLM stand for? After that, let's set the AI message. Let's give the content large language model. Okay, our chat history is ready. Next, let's create a question. Question: what is meant by large? Let me run this cell. There you go. As you can see, our model got the chat history and then created a question. Our model will generate an output based on this question. Our chain works very well. Let's go ahead and create a chain with chat history. Now we can build our full question answering chain. First, let's create a QA system prompt. Let me copy a prompt and paste it here. Here, we can want the model to be an assistant for question answering tasks. Our context variable is here. Now, let's create a QA prompt using chat prompt template. To do this, we're gonna use the prompt we just created. Let me copy this code and then paste it here. We're only gonna change the system message. Let me set QA system prompt. And then let's change this name QA prompt. Our QA prompt is ready to go. Before creating a RAG chain, let's define the functions we'll use. The first function we're gonna create is format docs. This function helps us join docs. Let's say def format docs. Let's pass docs. Let's set return \n \n. Let's call the join method. Let's write doc page content for doc in docs. Nice! The function is ready to join the docs. Now let's create a function that generates a contextualized question if chat history exists. Let's say def contextualize question. Let's pass input dict. Let's set if there is a chat history. If input dot get. Let's pass chat history. We wanna return contextualized QChain. To do this, let's write return contextualized QChain. Else return input question. Nice! Our function is ready to create a contextualized question. It's time to build a chain. Let's put it all together into a chain. Let's say RAG chain. First, let's use the Runnable pass-through class to return docs. Let me import this class from LangChain core runnables import runnable pass-through. Let's use this class runnable pass-through. Let's set assign. Let's give context. It's gonna be contextualized question. Let me use pipe and then let's set retriever and then let's type our function format docs. With this code, a question will be generated using the user input. What we're gonna do now is pass this question to the QA prompt. Let me use pipe and then QA prompt. Our prompt is ready. All we need to do is pass this prompt to the local model LLM. Awesome! Our chain is ready to use. Now let's take a look at how this chain works. First, let's create a chat history variable. Chat history equals, we're gonna leave it blank. Next, let's create a question variable. Question equals, what is LangGraph? And then let's create an AI message. AI message equals RAG chain. Let's set the invoke method. Let's give question. It's gonna be question. And then let's set chat history. Let's pass the chat history variable. Nice! Our model generated the answer. Now let's take a look at this answer. AI message. There you go. LangGraph is a Python module built on top of LangChain. As you can see, our model generated an output about LangGraph. Now let's add these messages to the chat history variable. Chat history Let's call extend. Let's set human message. Let's give content. It's gonna be question. Let's pass the AI message variable. Okay, the chat history is ready for another question. Now let's ask the second question. Let's write second question equals what is it used for? Now let's give this question to the model. Rug chain invoke. Let's set question. Let's pass the second question variable. And then let's set the chat history. Let's pass the chat history variable. There you go. The model generated the question based on the chat history. The model understood that the word it here is LangGraph, and accordingly our model generated the answer. Yeah, that's it. Today we covered how to build a RAG app with chat history step by step. Note that the link to this notebook is in the description. Hope you enjoyed. Thanks for watching. Don't forget to subscribe, like the video and leave a comment. See you in the next video. Bye for now.